Hello, I'm Peter Eijgermans from Ordina, Netherlands, and I work for JTech. There's a department of Ordina, and I'm a software developer, architect, or they call me also a codesmith at Ordina. And I have a talk about microservices or monoliths. And I'm also integrating a story about my rhino attack in Nepal. And it was 20 years ago. So I start with my Nepal Tibetan hat, that is the same region. And that I bought that after I was attacked. So it was, you see how they are walking. The Tibetans. Okay, here I start with the microservices monolith presentation. Here you see on the right hand a example of a monolith, and on the left hand side the microservices, the smaller parts of it. You recognize all those objects, I think. What I say, I've cycled from Holland all the way along. I can better start here. Here you see a little part of Europe on the left-hand side, and in the middle you see Nepal and also Tibet and the Mount Everest. And there I've cycled from Europe, from Holland through Turkey. And then I cycled through Iran, Pakistan, India, and then afterward, at the end, I go to Nepal and Tibet, and then I was walking in a park, in a national park, and I was that day. I was really attacked. Okay, I will show you some pictures about it and also integrate it in the talk. Here I am cycling in the mountains, you see. It was 20 years ago, so I was still, I was younger than, a lot younger. Here you have the rhino who attacked me. He was still waiting behind a tree. We were spotting him. And I saw a silhouette of the rhino, and we were walking in the bush and with some friends, and also a guide. He is nothing more than he has no weapon, but he can also he says to us, you have to climb up in the trees, climb in trees, because he is very dangerous. And we were very excited, and he heard that. He was listening and moving his ears. And then he suddenly, he was listening and smelling. He could not see us because he cannot see very well. And he wanted to attack us. He was really charging us. So what is so bad about monolithics anyway? Yeah, monoliths are there are a few good things about monoliths. Of course, the major advantage is that the monolith is one application, and it is quite and you have some few when you have cross-cutting concerns like logging or security features such as audit trails or dust protection. You can quite easily implement it and hook it to your components in your monolith. It's a major advantage. Another advantage is that you have less operational overhead. That means that you have it's much less to deploy a monolith. And you can also what I also tell you, you can easily hook up your cross-cutting concerns like logging and security features, and monitoring and testing is also easier. than with microservices. A monolith can have better performance since it has a shared memory between the services. It can be, the shared memory means faster communication between the services. Here you see my rhino is attacking me, but that was very. I was very afraid because I was standing on a branch which was as high as his horn. So I was afraid he was really attacking my tree and not the other trees where my friends are in. And he has a little one with him, you see. So that is always is also very was very angry. A microservice. Yeah, let's start. What are microservices? Microservices. Microservices. Here you see an example of. I think I skipped someone. Here you have let's go further with the monolith. Sorry, a monolith. I show you here, and this is one application, one deliverable you make of a monolith, and that's it. That is called an air file, for example. It is mostly a layer design, possibly a model view controller design. You see an example of a shopping cart application with a user component to log in and a catalog component to choose your products and an order component to order your product. And this monolith has also a database and some config files. It's mainly stateful. That means the application is aware of user state, for example, via sessions. And now I switch over to microservices. What are microservices then? Here you see the same application, the same shortcut UI application. And this is split it up in 3 microservices. That means you have to split up your service per function, or they call it also per feature. So you have here the user function, the order function of order service, they call it also, and the catalog function. You split your application, your monolith, you split your monolith up in 3 functions, and these functions we call, they are called microservices. So we have here 3 microservices standing apart from each other and communicating with each other via the internet network. Every microservice has its own database. There's also a design issue, the design pattern of it. And a microservice consists of a service registry. Why do you need it? Because microservices are talking with each other over the network and they cannot find each other very well. So they designed a server registry, a server discovery, they call it also, and you can register your service herein, and the other services can discover each other via the registry, the service registry. And at the top, you have a shopping cart UI, and we call it also your API gateway. And this is also an application. It is also a server, and it is very important for your microservice application because it shields your user or your clients from the complexity of your microservice setup. What does it do? It's the requests will coming in through the shopping cart UI or the API gateway, we call it. requests come in and it will be routed to the right microservices, one or two or more. And it will also get responses of the right microservices. And it will aggregate all the data and send it back to the client. This is what it mainly do, the API gateway. Other things that API gateway always do is, what I say, aggregate results from the microservices, but also masks failures, for example. When one service is going down or has timeout errors, it will return a cached or a default data. Other responsibilities are authentication, what the API gateway do, monitoring, load balancing. So there's a lot of things to say about this. What I also want to say is that the services are communicating with each other. When they find each other, they can communicate with each other via the REST protocol over HTTP, or what is preferable, of course, they want to, you can also communicate with each other with messaging. This is asynchronous. What are microservices? The benefits of microservices. It enables business agility. It's faster response to markets, and it is cost efficient. What kind of applications should be made with microservices? I will think about. This is also what I'm asking here. What for type of systems do you have to use microservices for what for type, and when not? Okay, for web shops, it is very preferable for newspaper, search engines, and in banks, for example. Capabilities. What are the capabilities of microservices? Microservice needs to be independent. Microservice can be deployed and developed and autonomously, and also needs to be scalable. Can be scaled, independent of the other services. What does independence also means? That the microservice is separate, is running separate from other microservices, what I told you. And they have to, it means also that they have to communicate via a REST endpoint or via messaging asynchronous. Via REST, when you talk via REST and over HTTP, then your request can be can be blocking because it is synchronous. I prefer to communicate within the microservices to communicate with messaging on an asynchronous way. Monitoring, the microservices need to be monitored via health checks and logs. Fast delivery is also a capability. For agility, the microservices needs continuous integration, continuous deployment, and any change to your local microservice is very easily, because you normally don't have to coordinate with other teams who are working on another microservice, because you are dedicated to one microservice as developer. It is easy to maintain, and a microservice needs to be resilient. What does it mean? Yeah, you have to easily to maintain means you can easily develop and understand. You can also easily understand a microservice, because a code in a microservice is restricted to one function of the business, and thus easier to understand and easier to maintain and easier to load, because it is not so big Microservice does also need to be resilient. It means that you have to handle failures. You have to handle errors because software, mainly in microservices, failure will always occur in microservices because microservices are distributed services over the internet. And one of the simple problems you can have is, and also structural problems, is that you have network latency. That is also a big problem. You have to handle it carefully. So the key concern of resilience is not how to avoid failure, but how to deal with failure. You have to deal with it. And what I say, microservices are distributed over all the internet. And yeah, there could be network latency or timeout errors. And you have to handle that. And you can use for this, for example, a circuit breaker to monitor the service, the state of these services. And when one service does not work well because of network latency, then usually the circuit breaker will stop the microservice. So, and it will return, for example, a stale web page or stale response. Here you see a list of toolings. It's better to, not to sum it up, all those toolings, but you see the resilience. I have talked about Hystrix already. For platforms, you can use Zool Proxy. It is Zool Proxy. You can use it for, like an API gateway when I talk about it. It will route your requests and aggregate your responses. Kubernetes, you can use this platform for automating deployments, maintaining and scaling your applications. For service discovery or service registry, what I also call it, you can use Zookeeper. Here you see my rhino again. He's still angry and he hears us. Here he's also, he wants to attack me. He is not. He could. I don't know if I have. Okay, we will see later how it's going well, but he's still angry, and the monolith is has not decided to attack me, not yet. Conway's law. Yeah, what is Conway's law? With microservices, you have also the problem that your organization should mirror your microservice architecture. And here you see an example of the a lot of big organizations, Google, Amazon, which these organizations all use microservices. And you see that these organizations have different architectures, and you see that the microservice architecture should mirror the organization architecture, because else it will not succeed. The organization, what it means, Conway's law, is that the organization has to change the benefits. Has not to change. Sorry, the organization had to change itself. For example, you have a team who want to who works like with Scrum, who works with Scrum and DevOps, and other organizations or other parts of the organizations like sales and account management are not working with Scrum and DevOps. Then it will not work. The microservice offset. Their agility is reduced, and then the organization should also be agile. So if the organization does not change, is not agile enough, the benefits of agility are much less. What I say. Microservices, what they say, have a lot of, there's much more complex monolithic applications. You can talk a lot about it. It is communicating preferably over the network via messaging, for example, or when you choose for this to make to use just messaging between microservices. When you choose for this, you have also a lot of other problems with it, and debugging is very difficult. On the other hand, monitoring is also very essential in the microservice architecture, but is well often forgotten. But it is very important because you have to you find your bugs very well and very fast. And the testing is very difficult. I will talk there about it later on. This is the question I have already answered in my talk now. Because REST is blocked. It can block your application, and that is not so. It's not preferable. I prefer messaging. Here you see a lot of complexity. What is about? There's a lot of more complexities about microservices, container management, skilled teams you need, deployments to production is also very difficult. Testing, I will talk about it later on, is also not so easy. Debugging async messaging application is also not easy. And the biggest thing you have to do is the organizational change. The organization needs to be agile enough for this. You also use multidisciplinary teams. Every team is responsible. Is responsible for one service, one microservice, and there should be no dependency with other teams. The individual teams should, multidisciplinary teams means also that every individual in the team should and could replace each other. Microservice architecture. I compare it with SOA and Unix. Is it just SOA? There's a question on the screen now, and similarities with SOA is our service has, each service has its own task, just like SOA. But the difference is that the microservice architecture services are decoupled and easily deployable. They are lightweight, scalable, and every service has its own database. So that's the difference. On the other hand, we have also the Unix Unix style pipeline. That is why do I call this here, because the Microsoft philosophy is similar to Unix. Do one thing, do one task, and do it well. So this is what's the similarity with Unix. Here is a lot of questions. Why would microservices not be beneficial? If your organization is starting with microservices rather than a monolith. B, your organization is not successfully strategizing for such compartmental design. C, members of a development team aren't as knowledgeable. The correct answer is D, because without proper monolith background, failure is will come also to your microservices. You make microservices. Design characteristics of microservices. A microservice has a single responsibility. Each service is responsible for a single part of your functionality, and you do it well. You have to do it well. An explicit publish interface means the user, has to be easily consumed by a consumer. Another design characteristic is DERS and lightweight communication. Lightweight communication via REST over HTTP or STOMP over WebSocket, for example. And also, what does mean DERS? What does that mean? It does mean deploy, update, replace, and scale. This will mean each microservice can be independently deployed, updated, replaced, and scaled. Domain-driven design and polyglot. So each service is full stack, and you can choose your own programming language or languages you want to how you make your microservice. And with the domain-driven design is a way of designing microservices, and you speak the same language as the organization. So it makes it easier to create, implement the right microservices for the organization. A few other questions. Why will the microservice architecture be beneficial? The correct answer is D. Less service interruption for file space. Different parts of the development team can manage individual parts of the microservice. That's a very important one, of course. And the other ones are easier to understand. Here I show you some microservice design patterns. The aggregator pattern. An aggregator could be a website, for example, and you see here a simple example of an aggregator which calls service A, service B, service C, and every service has its own caching and database. This is a pattern you can use, for example, for REST calls, making REST calls. Here also a chained pattern where service E, service B, and service C is dependent on each other. So the client is blocked until the whole chain of services is ready with the request and response. I have also here show you also here the asynchronous messaging pattern. This is this is what I prefer, the asynchronous part, because the other patterns I showed you before. Those are REST patterns, and that's a limitation of being synchronous. These patterns I show you now, and these patterns are blocking. I prefer asynchronous messaging for what, for example, you serve clients call service E, and service E calls service C, and service C is calling service B and service D via a queue or a message bus. Oh yeah, now my rhino is coming and attacking me, but how does that, is it going further? I don't know. We're going further with my microservice. How to convert a monolith to a microservice. I have here 3 little strategies to convert a monolith to a microservice. Stop digging, split your front end and back end, and extract services. Okay, strategy 1, stop digging. This is here you have an example about a request router that is also your API gateway, and you put your new code from your microservice in a standalone, a new microservice. Put your new code there. The request router, there's a API gateway, is for handling old and new requests. You see, old HTTP requests and new HTTP requests. And you have to make glue code for integrating the service with your monolith. That's a very simple one. You can also split your front end and back end. That is easy to understand. It's also it's only a little step forward to start. And you see here the last strategy, extract services. Here you define in step 1, you define here a coarse grain interface between the module and the monolith. In step 2, go further. We turn the module into a freestanding microservice. The monolith and the service communicate with each other via an API. It sounds very simple, but it is not so simple. But it is one step to make a microservice. Your first microservice, the first simple microservice, which has its own database. Is it a good idea to share a common database for a microservice? I want to explain you that. Here you see an example of my order service of my shopping cart. And you see here that the order service, there's a request coming in and to make a new order. And you want to place the order update the order table with the new order. But it is not good to update the customer table, which is running in the other microservice, the customer service, because when the customer service is not available yet, or there is a timeout, for example, or a network latency, then the customer table is not updated directly. I have a solution for this. When there is a new order and you register in the order table, you say that you have a new order, which state is new. And at the same moment, when you insert the order, you insert also in the same transaction, you insert a event, the state of the order, that the order is created in an event table. You do that, you do those actions in one transaction, one local transaction. And you have also an event publisher, which queries the event table and publishes your new state, your order created state to your other microservices via a message broker or a message bus. What are the drawbacks you face when working with microservices? There are a lot of drawbacks, of course. Write code to handle partial failure. I talked about it already. You have to deal with failure, because network latency, timeouts, programming errors. On the other hand, update multiple databases owned by different services is also not what you want. I explained it already. Testing in microservices and implementing changes are also very difficult. Integration testing in microservices is much more complex than with monoliths. So yeah, when you want to test a class, a service should need to launch others. When you want to test a class for a service, you should not launch another service, which is dependent on it. That's very difficult. Or you can also choose to use stubs, of course. Implementing changes that span multiple services is also very difficult. Making API changes of services affects all callers of the service. The problem with this is that you cannot force all clients to upgrade in lockstep with the service. Solution with the API changes is that you make an old and a new version of the service, and that they are running simultaneously. Deploying of multiple services, is also more complex than in Monolith. You have many more moving parts that need to be configured, deployed, scaled, monitored. The ecosystem is very complex of a microservice. This is what I'm talking about all this presentation. And reorganization, the organization has to change, has to be agile enough, and it's very difficult. Sometimes a step too far for organizations to mirror the microservice architecture. Do we need micro frontends? Yes, of course, I liked it, but I can explain you why. Here you see a simple slide about where we start, where do we come from? We start from the monolith, and then we split it up, the front and the back end, for example. But still, we have here frontend monoliths. And this presentation is mainly focused on the right-hand side picture, where we have split up our backend parts into microservices. That's beautiful, but we we still have a front-end monolith. We should break it up, of course. Here you see a micro front-end definition. It's made by ThoughtWorks, technically greater. And this is they're saying that you have to break up your front end into features. And each feature is owned by a different team. So I show you in the left-hand side, it is not what you want, but this is when you have a monolithic application, you have this type of specialized teams. You have a front-end team, you have a back-end team for the services, and you have a business team and operations team. And these teams are grouped about a skill or a technology. But what we want is a cross-functional team. We want a team which is grouped around a use case. In our case, user, order, catalog. And we want to have a team which is grouped around customer needs. And also we have to change our front end to it. When we use micro front ends together with microservices, we speed up our development, of course. We have a better customer focus. We can have direct feedback. We have direct customer focus because we have we are making features for the customer. Cross-functional teams, what I'm talking about it in the previous slide. We have specialized specialized teams per feature. Yeah, everything fits into your memory. It's simpler to develop a microservice with one team. And the ability to change frameworks from in the front end and the back end is also easy, because you're working on your own microservice, on your own micro front end, and you don't have to deal with other teams, what kind of framework you have to use. You can very easily change versions of a feature, and you can deploy independently. Here's a simple slide about how you upgrade your your microservices. And this is you have to choose. You can upgrade your version quite easily without any problems. That should be the case. But how does it finish my my Rhino talk? Yeah, one of my friends did not see that that my Rhino was standing next to my tree. So he made a picture of the beautiful Rhino you saw, and the Rhino was nearly 1 meter from me. And he made a picture, and he has an old camera, and it makes such a loud noise. So he ran away after his click, and he didn't see that I was in danger. So he was walking back. So the problem was solved, but it was it was scary. Okay, this is my talk. Thank you very much. Do we have questions? No problem. I will answer it. Thank you very much.